Good day everyone. We are Debayn Group and we're going to discuss Introduction to Travel Demand Forecasting or Classic 4-Step Forecasting Model. So what is travel demand forecasting? So travel demand forecasting is a systematic process used to estimate future travel patterns in the city or region. So how many trips will people make? Where will those trips start and end? What transportation mode will be used? And which roads or transit routes will travelers choose? So, ang travel demand forecasting is makatabang siya sa mga planners to estimate sa future transportation ang mga sa kailangan based on factors like population growth, land use, income levels, and travel behavior. So, magamit siya to design and improve sa roads, public transport systems, and infrastructure to meet future demand efficiently. So, ang example ni is if a city is growing, so ang travel demand forecasting is naka-estimate sila og anang pila ka people ang mogamit ana nga mga buses or cars or trains in the future para ma-help nga ma-avoid ang mga traffic congestion and improve mobility. So, purpose of travel demand forecasting. So, travel demand forecasting helps planners and engineers to first is plan transportation infrastructures. So, determine whether new roads, highways, or public transportation system are needed. So, transportation infrastructure is planning involves analyzing current and future travel needs, then designing appropriate facilities such as highways, transit systems, and pedestrian pathways to support economic growth and improve mobility. And second is predict future traffic condition. So estimate traffic congestion and road capacity requirements. So, it involves analyzing occurring traffic data and trends like sa population growth, vehicle ownership, and road uses to forecast how busy road will be in the future. Then, katabang ni siya help sa planners naka-prepare solution para ma-reduce ang congestion and improve transportation systems. Then, third is support urban planning, guide land use development, and transportation integration. So, it means kanisha is using data like travel demand forecasting and traffic predictions to guide roads, residential areas, business centers, and public transport systems should be located for better city development. Then, fourth is improve transportation efficiency. Design better traffic management and transit systems. So, siya involves optimizing road networks, reducing delays, and enhancing public transport so that travel time, fuel use, and congestion are minimized. So, example is if planners expect population growth, they can forecast future traffic demand and design infrastructure before congestion becomes severe. So, the most common method used worldwide is the classic 4-step model. So, ang first step sa transportation. Ang first step is ang trip generation. So, trip generation estimates how many trips are produced and attracted by different areas called traffic analysis zones or TAZ. It predicts so-called trip ends for each zone. The trip end may be classified as either original production to decide destination or attraction or equal na sila. Then kani siya ang first step sa transportation planning para ma-estimate ang numbers of trips that start or end in a specific area. So kani siya ma-determines kung anang pila ka trips are produced and attracted by different land uses at sa kanang residential, commercial, or industrial areas. So it helps planners understand travel demand in a given location. Trip production or P. Trips originating from a zone, usually residential areas. The home end of a home-based or HP trip or the origin of a non-home base or NHB trip. So ano siya is the process of estimating how many trips are generated by people leaving a location like sa home to work, to go to work and school, shopping, or activities. So ano siya is refers sa number of trips that originate from a specific area. So kanang usually is ang residential zone.
So next is the trip generation, factors affecting trip production. So the factors are, first is the household size and composition. So bigger families or families with different members like kids, workers, tend to make more trips. And then next is the number of workers in a household. So if more workers is equal to more daily trips, especially if na-joy work. And the number of students travel regularly to school. So maka-increase gyud siya og trips. Next is the household income. So if nang kay higher income, so kanang possible man jud nga magsigi ka og kanang shopping or mag-leisure or etc. So maka-increase gyapon siya. And then car ownership, proxy of income. So household with more cars usually travel more because it's easier to move around. So next is the trip attraction or A. So trips drawn to a zone like commercial centers, schools, and offices. So it focuses on the destination side of trips like asa mo ngadto ang mga tao or study or activities. And also, this includes HB or the home-based trips. So this is the trips that starts or end at home. And then NHB, non-home-based trips. Trips that don't involve home, like office to restaurant. So next is the factors affecting trip attraction. So these explain why people go to certain places. So floor area and employment opportunities. So bigger establishments and more jobs attract more people. And then next is the school and college enrollment. So if more ang students, then equal siya sa more trips going to schools. And then next is the other activity centers. So like places like transport terminals, stadiums, cultural religious areas, and then maka-attract siya og large numbers of people. So next is the classification of trips. So first is the home-based trips. So this occurs when the home of the trip maker is one end of the trip. So one end of the trip is home siya. So example kay if mato kag balay, then to school or work, and then after school and work, ato na pod ka balik sa balay. And the next is the non-home-based trips. Occurs when neither end of the trip is the home of the trip maker. So neither end is home. So example ani kay mato kag office, then restaurant, and then mall. So next is the time-based trips. So the portion of journey is different by different purposes, usually varies with time of the day. Thus, classification is often given as peak and off-peak period trip. So busy hours like morning and evening rush hours, off-peak period, less crowded times. This helps planners understand traffic flow during different times. So next is the person type based trips. So, travel behavior depends on people's characteristics. So, first is the income level. So, higher income may mean more travel. And then car ownerships, more cars is equals to more trip. And then household size. So, if daghan ang household, then daghan gyapon ang trip.
So, factors affecting trip generation. So, first, the population. So, more people means more trips because people go to school, work, and other places. The next, the household income. So, higher income means more trips since people can afford transportation and travel more often. The next, the car ownership. So, if people own cars, so they can travel anytime. So, trips increase. The next, the land use. So, the type of place affects trips. Like, for example, homes create trips while malls and offices attract trips. The next, the employment. So, more jobs means more people traveling to work. So, more daily trips are made. So, like for example, if a zone has 1,000 households, so it may generate 3,000 trips per day. So, for growth factor modeling, tries to predict the number of trips produced or attracted by a household or zone as a linear function of explanatory variables. So, the models have the following basic equation. So, we have here the equation that T sub I is equals to F sub I times the T sub I, where the T sub I, the number of future trips in the zone, and then the small t sub I, the number of current trips in that zone, and then the F sub I, the growth factor. So, the growth factor F sub I depends on the explanatory variables such as the population P of the zone and the average household's income or I, and the average vehicle of ownership is which is V. So for growth factor formula, F sub I is equals to P sub I to the power D times I sub I to the power D times V sub I to the power D is over or divided by P sub I to the power of C times I sub I to the power of C times V sub I to the power of C, where the subscript D, it denotes the design year, and C, it denotes the current year. So for regression methods, so it's just the same, the growth factor modeling. So it tries to predict the numbers of trips produced or attracted by a household or zone as a linear function of explanatory variables. So the models have the following basic equation. So T sub I is equals to F sub I times T sub I, where the T sub I, the number of future trips in the zone, and the small t sub I, the number of current trips in that zone, and then the F sub I, the growth factor. So the general form of a trip generation model is, so we have here the general form, which is the T sub I is equals to F of X sub 1, X sub 2, X sub 3, up to X sub K. And then the most common form of trip generation model is a linear function of the form, which is the T sub I is equals to A sub 0 plus A sub 1 X sub 1 plus A sub 2 X sub 2 plus A sub K X sub K. So the T sub I it is the number of trips. And then the x sub 1, x sub 2, up to x sub k, it's the factors, or like populations, the income, etc. And then the a sub 0, it is a constant. And then the a sub 1, a sub 2, up to a sub k, it's a coefficients, or how much each factor affects trips. So for trip distribution, so it determines where the trips go, and also it connects trip reductions and attractions between zones to form a O to D trips, or the origin destination trips. So data collection methods of origin to destination trips are household travel surveys, GPS and mobile phone data, and automated traffic counts. So like for example, trips from zone A may go to zone B or work, zone C or shopping, or zone D or school. So a common model used is the gravity model, so which assumes trips are more likely between zones that are closer and have more attraction.
A gravity model. It is the second step in the four-step transportation forecasting model. The most widely used and documented trip distribution model, and it is inspired by Newton's law of a universal gravitation. But instead of planets, it deals with people and location. As you can see, there are formula that T, or the TIJ, stands for the trips, and then P or PI is for the production, then AJ is the attraction, or the measure of attraction of the JIT zone for the trips of the purpose, then DI or D is the impedance or the distance, then N is the exponent, and M is for the total number of attraction. The next is the mode choice, which is the step 3 of forecasting model, is where we figure out of the how of transportation. After knowing how many people are traveling and where they are going, we need to predict which transportation type they will choose. For example, the private car, bus, jeepney, motorcycle, walking, bicycle, or the rail transit. There are factors affecting the mode choice. First is the characteristic of the trip maker. This is all about the person's situation before they even leave their house. Their choices are limited by their lifestyle. All about the car availability, position of driving license, household structure, income, decisions made elsewhere, and about the residential density. The second is the characteristic of the journey. This is about the type of trip, or it will answer the what or when. The mode choice is strongly influenced by the trip purpose, time of the day when the journey is undertaken. The delayed trips are more difficult to accommodate by the public transport. And then third is the characteristic of transport facilities. And there are two types of factor of the characteristic of transport facility: the quantitative and the qualitative. The quantitative factors are, these are the numbers people calculate in their heads, like the relative travel time, relative monetary cost, and the availability and cost of parking. Then for the qualitative factors, there are the vibes and the feeling, things that are hard to measure with a ruler. About the comfort and convenience, reliability and regularity, protection, and security. A good made choice should include the most important of this factor. Then there are types of model split model. types of modal split. First is the trip and modal split model. It is used transportation planning to estimate the proportion of the trips made by different transportation modes based on characteristics of the trip, region, or destination. The trip and modal is explain the planners use to trip and models to predict the future. Instead of looking at the whole journey, they look at the start or end point.
So the example of trip and modal split models. So we can see here the table consists of 3 columns. So the first column is the household income, the second column is the car ownership, and the third column is the predicted mode. So the first row, we can see here that the high income then has consist of 2 cars, and then the predicted mode is a private car. And then the second row is the middle income, has 1 car, and then the predicted mode is the mixed modes. And then the low income has no car, and then the predicted mode is the public transportation. So typical output example model share for residential zone. So we can see here the table has 2 columns. So the first column is the mode and the second column is the percentage. So the private car is 50%, the bus or a jeepney is 30%, the motorcycle is 15%, and then walking is 5%. So this means that 50% of trips originated from that zone use private cars, while 30% use public transportation. So the second type of modal split models is the trip interchange modal split models. So it used in transportation planning to determine which transportation mode travelers choose between a specific origin and destination pair. Unlike trip and modal split models, which focus on characteristics of the trip origin, this model considers both the origin and destination of the trip, including the travel condition between them. So the example of trip interchange modal split models. So we can see here the table has consists of 5 columns. So the first column is the mode, next is travel time, cost, comfort, and likely choice. So the first row is the car. It travels 20 minutes, and then the cost is high, comfort is high, and likely choice is preferred by high-income travelers. And then the bus, travel time 30 minutes, cost low, comfort moderate, likely choice preferred by commuters. And then lastly is the motorcycle, travel time is 15 minutes, cost moderate, comfort low, and then likely choice is the preferred for short trip. So the third type of modal split models is the aggregate and disaggregate models. So aggregate and disaggregate models are approaches used to analyze and predict transportation mode choice behavior in travel demand forecasting. Aggregate models analyze travel behavior using group or average data rather than individual traveler data. The analysis is done at a zone level or population group level. And then the characteristics of aggregate models. So it uses average values for groups of people, and then data is usually collected for zones, districts, or cities.
I will be discussing the classic 4-step forecasting model. So we have here the types of modal split models, the aggregate and disaggregate models. Disaggregate models analyze travel behavior using individual level data. Each traveler's characteristics and preferences are considered. So meaning both the characteristics of the travelers and its preferences are or being considered. We have here the factors considered in a disaggregate models. So first is the travel time, which is the time frame that the travelers must have, and also the travel cost, income, car ownership, trip purpose or the objective of the travelers, the accessibility of the transportation modes. So when we say travel time, so as I've said earlier, it is the time frame. So the cost, which is, we all know that the most or one of the most important factors that we should consider as a traveler. So also the income and also the vehicle that we are gonna use and the purpose or the objective. We have here the example of a disaggregate models. As we can see at the table, we have at the first column the persons, second column is the income, the car ownership at the third, and the fourth is the mode of chosen. So first person or the person A, let's say he or she has a high income, owns two cars, and those cars or the mode of chosen is the private car. However, the person B has a low income, no car in terms of car ownerships, and the mode of chosen is bus. So this model analyzes the individual decisions rather than averages. So individual decisions. So as we can see, person A has a more capacity than the person B. So in comparison, person A has higher income than person B and owns more cars or vehicles than the other person or person B. The comparison of the disaggregate and aggregate models. So we have three columns. First column is the feature, the second one is the aggregate model, and the third one is the disaggregate model. So under the features, we have the data level, the complexity, the accuracy, and the data requirements. So for the aggregate model, in terms of the data level, it is a group or zone data. When in terms of the complexity, it is much simpler, and the accuracy is on moderate level. So, and the last one is the data requirements for the aggregate model, which is lesser compared to the disaggregate model. When in terms of the data level, we have the individual data, so it is actually the opposite. So when in terms of complexity, it is more complex than the aggregate model. So but when in terms of the accuracy, it is much higher than the aggregate model, and also the data requirements are more. So we have here the binary logit model. E is higher than the other, then that mode is chosen. But in transportation, we have this utility also. Here is the travel cost, and this can be represented as, so you can see at the presentation the formula and also the notation. So C subscript ij is equal to a sub 1 t raised to v subscript ij and so on, plus the delta. So next is the travel cost. If the travel cost is low, then that mode has more probability of being chosen. Let there be two modes, m is equal to 1 and 20. Then the proportion of trips by mode 1 from zone I to zone G is p raised to 1 subscript ij. Let c raised to 1 be the cost of traveling from zone I to zone G using the mode 1, and c squared subscript ig be the cost of traveling from zone I to zone G by mode 2. So here are the three cases. If c squared subscript ij minus c raised to 1 subscript ig is positive, then mode 1 is chosen. The second is if its difference is negative, then the mode 2 is chosen. And then the last one, if it is equal to 0 o kung ang difference nila is equal to 0, then the modes have equal probability. So at the presentation, we have here the formula. This is the relationship is normally expressed by a logit curve shown in the figure. So the logit curve can be shown at the next slide. So the proportion of trips by mode 1 is, so this is actually the proportion, which c subscript ij is equal to the generalized cost, and the beta is the parameter for calibration. This is the figure of the logit function that shows the proportion of trips by mode 1, which is the ratio of the t raised to 1 subscript ig to t subscript ig against cost difference. So actually we have there a curve. So this is actually the representation of the what we call logit function. So I guess that would be all for my presentation. For my part.
So for the continuation of the classic 4-step forecasting model, this is for traffic assignment. So traffic assignment determines which route travelers will take on the road network. So trips are assigned to, number 1, specific roads, 2, highways, 3, transit lines. And the goal is to estimate traffic volume on each road segment. So that's the traffic assignment. So this is the example for the traffic assignment. So example, if 5,000 trips travel from zone A to zone B, number 1, 3,000 may use the main highway and 2,000 may use the secondary roads. So these step help planners determine the number 1, road congestion, 2, traffic volumes, and 3, level of service or LOS. So this is the common traffic assignment method. So number 1, all or nothing assignment, or it assigns all trips between an origin and destination to the single route with the shortest travel time or minimum cost. So the principle of this all or nothing assignment is travelers always choose the shortest path or minimum travel time or cost, and all traffic is assigned to that path. It's just because it is short and it is convenient road, so everyone will pass that road and it will lead on to traffic. And yeah, so the next step is step 1 of all or nothing assignment is determine origin. Destination or OD trips obtain the number of trips between zones from the trip distribution stage from origin to destination. So zone A to zone B, trips is 500 trips. So step 2 is identify the possible routes. So determine the available routes between the origin and destination. So route 1 and distance is 8 km and travel time is 10 minutes. And route 2 is 9 km and travel time is 12 minutes. And route 3 is 7 km but the travel time is 15 minutes. So you see the difference between the route 1 and 2 and 3. So the route 2 is far, but it's in between the 10 and 15 minute ride. So step 3 is to select the shortest route. Shortest route is route number 1, which is in 10 minutes. So step 4. Assign all trips to the shortest route. So route 1, trips assigned 500, route 2, 0, route 3, 0. So it makes sense when you said na you can determine which route you can use. It's because route 1 is the shortest route and it has the shortest time. Oh, it doesn't have the shortest distance, but it has the shortest travel time, which is the 10-minute travel time and an 8-kilometer distance. That's all for my topic. Thank you.
So for the all or nothing assignment, we have 3 assumptions. The first one is travelers knows the shortest route. Second is travel time does not change with traffic volume. And third is no congestion effects are considered. So for the second common traffic assignment method, we have user equilibrium assignment or UE. Traffic assignment method where no traveler can reduce their travel time by changing routes. At equilibrium, all used routes between an origin and destination have equal travel time. So this concept is based on John Glenn's Wardrop's first principle, commonly known as Wardrop's first principle. This principle states that the journey times in all routes actually used are equal and less than those which would be experienced by a single vehicle on any unusual route. This means that drivers choose routes that minimize their own travel time. It also means that if one route becomes congested, some drivers shift to other routes. So eventually, travel times become balanced among the used routes. So its concept in reality, the traffic distributes across multiple routes, not just one. For example, for route 1, based on the table, as you can see on the table, on route 1, we have travel time which is indicated as 20 minutes. For route 2, the travel time is 25 minutes. At first, most drivers choose route 1 because it shows in the table that the route 1 has a less travel time than route 2. However, as traffic increases, route 1 becomes congested and travel time increases. Because mostly man jud kay ang pilion man jud sa mga drivers is ang faster way na makaabot sa destination. So that's why they choose ang pinakagamay nga travel time. So therefore, since mostly man kay ang pilion man is ang route na mas gamay ang travel time, so that's why over time route 1 can become congested. And if damo na ang mo use anang route, so magtikada mo na ang driver sa dira, so travel and traffic is present, so travel time increases. So drivers start shifting to route 2 when that happens. So eventually on route 1, the traffic has 600 vehicles and travel time is 22 minutes. So for route 2, 400 vehicles are present and travel time is 22 minutes. So both routes now have equal travel time, reaching user equilibrium. So for the third traffic assignment method, we have system optimum assignment. So traffic assignment methods where traffic is distributed in a way that minimizes the total travel time of all vehicles in the entire transportation network. Unlike user equilibrium, where each driver chooses the best route for themselves, the system optimum approach focuses on what is best for the entire system.
So the system optimum assignment. So what is the principle of system optimum assignment? So it just states that traffic should be arranged so that the average travel time of all users is minimized. So what does this actually mean? So the system operates at maximum efficiency. Individual travelers may not necessarily get the fastest route, but the overall network performance improves. So the concept behind the system optimum is that it minimizes the total travel time of all travelers in the network. So in this approach, some drivers may take longer routes so that the overall traffic congestion in the network is reduced. So let's say, for example, 1,000 vehicles travel from zone A to zone B. So we have available routes, route 1 and 2, and the travel time without congestion of route 1 is 20 minutes, and for route 2 is 25 minutes. So if we will use the system optimum assignment, so this will happen. If everyone chooses route 1, congestion increases and travel time becomes 35 minutes. So under system optimum, so the traffic may be distributed. So from route 1, we have vehicles of 600 and the travel time of 25 minutes. So at route 2, there are 400 vehicles and the travel time is now 25 minutes. Although some drivers take a longer path, the total network travel time becomes smaller. So the difference between the assignment methods, so we have the route choice for all or nothing is one shortest route, user equilibrium, individual best route, system optimum is best for entire system. So for the congestion, for all or nothing, it is ignored. For user equilibrium and system optimum, it is considered. So for the objective, all or nothing is the shortest path, user equilibrium is equal travel times, and system optimum is minimum total system cost. So realism for all or nothing is low, for user equilibrium is high, and for system optimum is very high. So in summary, so we have a step, trip generation. The question answered is how many trips are made, and the output is number of trips. For trip distribution, where do the trips go? Output is origin to destination matrix. So in mode choice, what transport mode is used? So the output is mode share. And for the traffic assignment, the question is which route is used? So the output is traffic volume on roads. So we have a simple example. Trip generation, estimate how many trips residents make daily. And for the trip distribution, identify where these trips go: business districts, schools, or malls. Now for the mode choice, determine whether people use jeepneys, buses, cars, or motorcycles. And the traffic assignment, predict traffic volumes on major road like Ormoc to Alvera Road or other arterials. Thank you for your attention.